In this lesson, we're going to analyze our data sets when they're in data displays. So first one we're going to review is a dot plot, which is a graphical display used when working with smaller sets of data. So we've got the example, students in a class collected data on the number of minutes some of them spend brushing their teeth every day. The data is shown in the dot plot below. Question number 1, how many students were surveyed? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 students were surveyed. Number 2, what was the shortest time somebody spent brushing their teeth? So we are measuring in minutes here. The smallest value that is recorded is 1.5 minutes. Number 3, what's the longest time somebody spent brushing their teeth? I can see over here we've got 2 people that brushed for 4 minutes. Number 4, how many students brush their teeth for less than 3 minutes, not including 3 minutes? So here's 3, not that person. We've got 1, 2, 3, 4, 5, 6 people that spent less than 3 minutes. A second example, we've got a dot plot below represents the number of goals scored at the boys soccer team for every game so far this season. Number 5, what's the most common number of goals scored? We've got 3 games where they scored 3 goals. So that's the most common amount of goals. Number 6, how many times did the team score 4 goals? There was 2 games where they scored 4 goals. 2 games. Number 7, what was the range in the goals that were scored? Remember, range is going to be maximum minus minimum. So the most we have is 5. The least we had was 0. Do you see that over there? So 5 minus 0, the range is 5. What is the median number of goals that were scored? So we're looking for the middle here. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total. So if I was looking for the middle, I could take 12 and divide it in half. 12 divided by 2 would be 6. So my middle number should actually be somewhere between the 6th and the 7th because this is even. So let's see, we've got 1, 2, 3, 4 on that side. Just showing you how we're working our way to the center. 1, 2, 3, 4 on this side. I think I can do a 5th on each of those. Yeah, see how that, we have 5 on the left, 5 on the right, and there's 2 left over in the center. That's going to be the 6th and 7th one. So I need to take the average of those 2. Those are 2 3-point goals games there. So 3 plus 3 divided by 2 gives me 6 over 2. Or as you can imagine, the middle or median value is going to be 3 because our 6th and 7th value were 3s. But you might have a different example on Delta Math. So I wanted to make sure I modeled that for you. Our next data representation is a histogram, is a graphical display using bars to represent intervals of values from a data set. So there's actually like ranges that represent the bars. Let's look down here. We've got a teacher put all of our students' quiz scores up on the representation below. It is points down here at the bottom, and students that scored between 40 and 49 points are in that first group. And there is 1, 2, 3, 4, 5 students that scored in that range. So a histogram is like a bar graph, except it uses intervals. So let's look at our questions. Number 1, what was the lowest possible score of the students in the class? We were kind of just looking there. The lowest that's recorded is a 40. Number 2, how many students are in the class? We've got 5 plus 7 plus 4, another 5, 4, and 3. When you add all that up, we can have 28 total students. Number 3, how many students scored more than 59 points? Kind of just like the earlier problem, more than 59. So here's 59. We want these groups. So that's going to be 4 plus 5 plus another 4 plus 3 gives us 16 students. Number 4, how many students scored less than 70 points? So here's the 70. We want these 3 groups that scored less. So 5 plus 7 plus 4 also gives us 16 students. And number 5, what's the highest possible score of the students in the class? Looking at our intervals here at the bottom, the highest that they have recorded is a 99. Another example with a histogram, this graph represents data collected by students on the number of social media posts that they made the previous day. Number 1, what's the most common number of posts students in this class made? Which one has the highest? So on this, we've got number of students, 5 students said that they made 10 posts. So what's the most common number of posts? 10 posts, because the most students recorded. That's how many social media posts that they made the previous day. Number 2, how many students made 5 posts? So again, we've got social media posts here at the bottom. We have 3 students. Number 3, what's the median number of posts made? The middle. So let's see how many we have. Total students, we have 2. I'm going to label it up here at the top. 2 plus 4 plus 1. I'm here on 3. A 2 and a 2 plus 4, a 2, and then that 5. Total number of students is 25 students. So to find our middle, let's take 25, divide it in half. Which student number would be in the middle? So 25 divided by 2 is 12.5, or we're going to look at the 13th place. So let's go through here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is going to land somewhere in that 7th column. Kind of the same way on the other side, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You still have that 13th circled, okay? So we were in the 7th column. 7 posts was the median number made by students. And number 4, what's the range of our posts? Maximum minus our minimum. We have 10 minus 0, or 10 posts would be our range. The third data display we're going to look at today is a box plot, sometimes called a box and whisker plot. Shows the distribution of data using a 5-number summary. Below, we have the top 12 musical artists weeks at number 1. Create a box plot using this data. So I'm going to use the calculator to find these minimum, maximum, first quartile, third quartile, and median. Let me make a note of that. We're going to use the calculator, and then I'll show you how to build that box plot. All right, new document, list and spreadsheets. We're going to put in our data. We have 34, 42, 50, 34, 52, 34, 79, 87, 37, 60, 59, and 47. It said the top 12 musical artists. Looking at my column, it says that my 12th value is 47, so I entered all 12 there. We're going to go menu, statistics, stat calculations, one variable statistics. This is all okay. This is all okay. Use that tab key to get you to the OK button. All right, minimum value, arrowing up. Our minimum was 34. Q1 is 35.5. Median is 48.5. Q3 was 59.5 and max is 87. All right, a box and whisker plot. I always like to start in the center. Our center bar is going to be based off the median. So I'm going to go to 48.5 45. So this graph, not at 45. I'm trying to get close to 48. So maybe somewhere about here is going to be my median value. To the left and the right, we have our Q1 and our Q3. So I'm going to go and do Q1 next, 35.5. Here's 35. We can just be really close there. That's my Q1 value. And Q3 is 59.5, very, very close to 60. There's Q3. Now those three values make the box. And then you have those whiskers that are your minimum and maximum. So to the left, we would have our minimum, 34. This is very close. Pretend that looks better than it does. 34, very, very, very close. And then maximum is 87. So here's 85, 87, about here. And you would draw your lines out to those minimum maximum points. Let me label that. This is our minimum. This one's our maximum. So let's use the data that's represented in the box plot below to answer some questions. Number one, what's the value of the second quartile? This is a new term that we haven't used yet. It's just another way to refer to our median value. Notice median sits right between Q1 and Q3, so sometimes it's referred to as our Q2. So looking at our graph, that's 60. Number two, what percentage of data values are between 60 and 70? So on our box and whisker plot, it's broken up into 4 segments. So each segment is representing 25% of our data. So for number two, we're looking at which percentage is going to be between 60 and 70. That's this segment here, so just 25%. Number three, what's the range of the data? This is going to be a maximum minus our minimum. So looking at our box and whisker plot, our maximum is 80 and our minimum is 15. 80 minus 15 is 65. Number four, what's the minimum value? We just used that. 15 was our minimum. Number five, what percentage of data values are less than 60? Well, there was 60, so we have 25 and another 25. 50% of our data is going to be less than 60. Number six, what's the value of the upper quartile? New way to write Q3, right? Lower quartile is going to be Q1, upper quartile is going to be Q3. That Q3 value right there at 70. Number seven, what's the maximum value? We've used this as well, 80. Number eight, what percentage of the data is greater than 50? Here's 50. So we've got 1, 2, 3 segments or portions that are 25%. That means total, we've got 75% of our data greater than 50. Number nine, what's the value of the first quartile? Again, that could be referenced to as lower quartile. But this is your Q1, which was 50, the left side of our box. And last question, what's the value of the median? That's your center line, your Q2, your second quartile, your median. We had it there at 60. So mostly review today, you definitely look at dot plots, histograms, box plots in earlier grades and earlier content. So we're just interpreting and analyzing these data sets. We're going to continue working with these in our next lesson. Let me know if you have questions, guys. Have a great day. See you later.